Hi everyone, Ali here. So I wanted to demonstrate how to do problem 8 on WebWork 6 to help us prepare for the final, because I know a lot of people were having trouble with problems like these where it's Hooke's law. So let's start. So a force of 2 pounds is required to hold a spring stretched 0.6 feet beyond its natural length. How much work is done in stretching the spring from its natural length to 0.9 feet beyond its natural length? So first, we're going to have to know Hooke's law. The Hooke's law formula represents F equals K times X, where F is the force being applied, or F is the force, and then Kx is the constant times the displacement. So to help us set up our integral, we can, since we know it's a force of 2 pounds, we can set it up as 2 equals 0.6x, because 0.6 feet represents k, because it's our constant. And then to isolate x, we can divide 0.6 on both sides, and we would get 10 over 3, because 2 divided by 0.6 is 10 over 3. So we can set it up as the integral from 0 to 0.9 of 10 over 3x dx, the bound being 0.9 because we're stretching it from its natural length to 0.9 feet beyond its natural length. So now we can solve the integral. So to solve, we're going to add an exponent, or we're going to add 1 to the exponent, of course, and then divide by 2, but we know that dividing by 2 is the same as multiplying by 1/2. And so after we do that, we get the integral from 0 to 0.9 of 5 over 3x squared. And then now we can solve. We can plug in 0.9 for x, and 0.9 to the power of 2 would equal 81 over 100. And so then we can multiply 5 over 3 times 81 over 100, and we get 405 over 300. And then we can simplify that to be 1.35, and then it would be in feet per pound. And then we can ignore the lower bound because it's 0, so if you plug in that, it would just end up being 0, and we'd be subtracting by nothing. So yeah, that's our answer. I hope this helps, and see you all.